Alright, in this video we'll be going over the GCD greatest common denominator problem. And to start off, here's the problem description. Given two non-negative integers, a and b, find GCD a and b, the function that we got right here. Greatest common denominator of two integers, m and n, is defined as the greatest integer g, such that g is a divisor of both a and b fit in a 32-bit signed integer. So this one actually just extra. Note, do not use library functions. In particular, whenever we're doing this one, this means that we're not going to import math. We're not going to import anything. So start off, I got a solution to where it is an O of n. So this time complexity of O of n and space of O and n. So the bigger the numbers that we're going to plug in, the longer it's going to take for this solution. So to start off with the umpire, let's go through the understanding. So here I have two test cases that are going to go ahead and let's see here that we have. Starting with the first one is 6 and 9. So it would be 3 because, all right, so the whole point of, let's actually take a quick moment to understand what greatest common denominator, what it means when it's a greatest common denominator. It's pretty much what's the number, the smallest possible number that evenly divides for both numbers. Usually you see this in fractions to find to go ahead and count the denominators. So that's usually one of the cases it'd be, or to, yeah, that's pretty much how that would work out. So you could count the denominators. But for this case, we're not using it for that. We're just trying to find the number itself. We're not doing any other math besides just finding the number. So above, it's already, when I'm looking at this, I'm thinking of a few tools that we're going to use, but we'll get to that in the matching portion. So again, looking at our example of our GCD of 6 and 9, between both of these numbers, 3 is going to evenly divide by 6 and evenly divide by 9. So that's how that's going to go out. And then for our second case, same thing, 18 and 24. What two numbers evenly divide? The smallest number that can evenly divide between both of them, well, it's going to be 6. And to prove that, I actually have the calculator here to show it. So starting with 6 and 9, so 6 divided by 3, that's 2. We have a whole number. If it was anything like, say, 5 divided by 3, let's say 5 divided by 3. Notice that we have a bunch of, it's not a whole number. So it's more of a floating number, or a double. It's what this is. So we can look at it. We could constantly divide it. So let's say 9 divided by 1. Of course, that's going to be by itself. That's going to be the obvious one. 9 divided by 2. Again, 4.5. It's not an integer. And then we have 9 divided by 3. Okay, that one works out. Perfect. So 9 divided by 3 is 3. So we can confirm it. Our second case, what was it? 1824. So let's do 18 divided by 6. The smallest number is going to come out as 3, so 6 works out. And then 24 divided by 6, 4. So this is the 6 is what's going to have to come out. So we're pretty much going to be going from the way we're going to test this out is we're pretty much going to be dividing it by itself. And then we're constantly going to go ahead and go down. So right now it's 1. It's not even. Let's see. So 2, 3, 4, 5, 6, 12. Okay. I get the wrong number. So start from 24, 3, 2, 1. We're still floating. Even 20. Yeah, we're still floating. Same thing. So now we go ahead and jump to the next part. 19. Same thing. 18, 17, 16, 15, 14, 13, 12. All right, so 12 works out. While 12 is evenly divisible, the issue is it's not evenly divisible by 18. It shouldn't be. Yeah, see? So it has to be divisible by both to be common. The whole point is a common, um, greatest common denominator. Excuse me. So while it works for one number, it has to also work for the other. So that's kind of what we're doing here, checking back and forth. So then, again, so 24 divided by, it was 12, so 11. All right, 11, okay. And then 10, nope. And now we're down to our single numbers, 8. All right, 8. So 18 divided by 8, nope. That is going to be a double. So we'll go ahead and just move on to the next number. 24 divided by 7. All right, 6. All right, 6. Now, it's saying that it's divisible by 4. What about 18 divided by 6? Perfect. It works for both numbers in both cases. So that's pretty much how we're trying to program this. I showed it just an example of what I'm doing just so we could get the understanding out the way. All right, so let's go ahead and jump into our plan. So let's get to P, our plan. And in our plan, so obviously we're going to take the input of both numbers. So let's go ahead and start just by defining our, I'll just call it function GCD. And obviously we're taking it two numbers. Excuse me. We're taking our two numbers, A and B. All right, A comma B. All right, so A comma B, we have our function. Cool. So what is next? Looking at our test cases, let's say, for example, the 18 and 24. We're not going to jump straight to 18 for this. The way how I'm thinking is the plan of, I'll go ahead and get to it. Actually, now we have that. I actually didn't get straight to the matching portion. So real briefly, let's go ahead and go back and just say M and slow down a bit. So M, obviously right off the bat from what I explained, we're going to be using our mod operator. See, this is what happens. I jumped into it. All right, so we have our mod operator, and then we're going to be comparing. So we're going to look at if, else, this size comparison. So let's get some alligator teeth in there. Alligator mouths, I call it. All right, alligator mouths are out the way, and I think for the most part that's going to be it. We're just going to be using mod operators, and we're using if else, and we're comparing these numbers. So yeah, those are the tools that we're using. So jumping back to our planning, which I should have slowed down on. So we had said that we had a function of GCD being A comma B. So already we have this. Now we go ahead and move on to the next part. We obviously need to find what's the biggest number, so we can start going down, because if we just jump to 18 is going to work for one number. It could potentially work for one number, but it may not work for the other, which it's easier to start from the biggest number and go down. It's probably going to be the best way to get through it. So in that case, let's go ahead and say we're checking for the biggest number. So we would say if A is bigger, this is where we start using it. Well, is bigger than B, then we're going to have to also define X. Now, X, what's X? X is basically going to go ahead and be what is being divided by. We're checking that. So we're just going to define it. It's going to be just a 0 for now, but it's going to be declared based on which is the biggest number. So again, if A is bigger than B, in that case, X is equal to A. Else, then it's just going to be X equals B. So that's kind of the whole plan of it. And then from there, what's next? Well, we're using, yeah, I'm sorry, I forgot to add this part. I'm looking back in my notes. So I was going to use a while loop. This is actually going to be what makes this is actually going to be what we're working off of. So we're going to have an infinite loop. So infinite. All right, we'll just use this infinite while loop. So while we have this infinite while loop, we're pretty much checking the whole time. If let's see here. So if a is divisible by x and b divisible by x evenly, then let's see here. We're going to go ahead and just return. So if it just so happens that our number works out perfectly, we're just going to return x. And that's it. That's pretty much what we're doing. We're looping through it. So that means that whatever the number is, it has to be both evenly divisible. That's pretty much how having no decimal points works. It's just evenly divisible. So what gives? All right. The elephant in the room of this is, what if it just doesn't, we have to just keep going. If it doesn't work out, if whatever our first number is and it just doesn't work, we have to go ahead and subtract. So else we're going to go ahead and subtract x by 1. So x minus 1. In this case, the way we could write this is x minus equals 1. So I'm just going to have that for noting. And we're pretty much looping. Like at some point, one of the numbers is going to go ahead and work. It will work because you're constantly going down until you find some sort of even number. And yeah, that's kind of how that's going to have to work out. It is very time consuming, this plan, how it's going to work out. But it's one of the best things. Looking at it, I already have an evaluation for it that maybe it's best to start from the smallest so you have less time to go from there. But for the sake of this one, I will just be going forth with the largest example. So looking at it after planning it, let's actually go ahead and code out our plan. So again, we have our def. Actually, just going to go ahead and copy this part. So we're going to have our def, our function, GCD, and that is going to be, we're pretty much checking. So we got our inputs. We are checking if, let's see here, A is bigger than B. Then in that case, we're going to go ahead and say, ooh, that's the part where I forgot again. I didn't look carefully. We're going to have to declare our X first. Our X is going to be 0 for now. So if A is going to be greater than B, then in that case, X is equal to A. Again, we want the biggest number so we can go as close as down to 0 as we can, and we'll find our greatest common denominator. Else, if it's not bigger, then it's actually supposed to be lowercase c. Lowercase c, then x is going to be equal to b. All right. So we found our bigger number. All right, we're this far into it. Now it's actually down to the de-incrementing part. So while true, so we'll say while 1. What we're going to be doing in this while loop, or infinite while loop, is now to check if A and B are divisible. So let's take this part again. And the way we're going to be doing this is here. Let's actually finish this up. The way we do this is if it is equal to 0, meaning there are no remainders, so it's an even number. And this part, copy, paste. So it will look something like this. This is what the condition is going to be if they're both divisible. If they're both evenly divisible, then we're going to return x. That's only if it's true. Then the whole program ends from there. Else, we're going to go ahead and take x, subtract, equal 1. And that's pretty much it. You're pretty much going through this. You're pretty much liar. So let's go ahead and review this real quick. We have our two inputs, A and B. We're going to declare x equaling 0, meaning that that's the GCD. That's the GCD that we're trying to get, but we're going to call it x. Excuse me. Yeah, x is our GCD and we're starting from 0. We are checking if A or B is bigger from this chunk right here, from this part. If A is bigger, x equals A, else it's B. It's nothing else besides that. Afterwards, we're going to have an infinite loop where we are checking if A is divisible by x evenly and B is divisible by x. Only way that's true is if we're constantly subtracting x by 1. Until like the way how I showed you in the calculator example a couple minutes ago. Until we just land to a number that just works. That's pretty much how we're doing things. So yeah, it's pretty much how that whole program works. Again, so kind of looking through it, and from the planning portion, I am umpire. We would review it, and I guess I'll take the time to review this one. So reviewing, obviously, this is not the most effective way after like running through the program. And I think the only difference that I would check is if it's actually smaller. So if A is smaller than B, then x would equal B. Ooh. That's probably how I would do it. And then else x equals B. Sorry, x equals A. And that way you have like less time. Realistically, I could have just started with I could have just started with 18 and then gone down, so it's less time. It's still going to be O of n regardless of it, regardless of the size of it. But that's pretty much how that's going to go. I mean, if it's not divisible. Oh, one more thing that I did not consider here too is what about the case of what if A and B are equal to 0? So what gives there? What do we do? Well, in truth, you can't divide 0 by 0. You know, there's nothing divided by nothing. You just can't do that. So in this case is that if they equal each other, if we would probably have a condition where if A equals 0 and B equals 0, then we would just simply return 0. There's nothing to return. I think looking at this, I might just actually add it up here. Now that I think about it, let's fix that up. And let's just say elif. And then if A is equal to 0, let's actually keep this part. And then and is equal to 0. Right? Return 0. So looking at it again, yeah, starting with this one, we're checking if both A and B are not 0. I mean, if they are 0. If they are 0, return 0, call it a day. That's it. We move on. Else, we're going to go ahead and go through this. It might be best, now looking at it, it would probably be easier solution to this, just fix this by just having A be less than. And that's pretty much how that's going to go. We're pretty much checking of that. That's actually the simple fix to it. We would just flop the alligator head facing the other direction and call that a day. Then we're checking if it's divisible, and that should be slightly faster. you're not going through the highest number, but eventually you're gonna end up going. You're gonna crash into the uh, GCD of both numbers. And if you don't, then uh, it's probably just going to be divisible by one. The only numbers that it's almost like prime numbers. Now that I think about it, well, probably would be best to have that in the matching. Now explaining it, prime numbers. Another thing that we have done on this channel is loop through prime numbers because there's no other numbers that are divisible besides itself and one. So we're pretty much kind of doing the same thing, except we're finding a common denominator. So that's how that would work out. That would be my review portion of it. It's just to go ahead and fix that out. The conditions of what if both numbers equal zero? Well, return zero. And what if what would probably make this faster is we would just make it smaller. We take the smallest number and start from there, and then remove. So that's pretty much it.